Welcome for the next session of computer graphics. Today we will study about hidden surfaces, the importance of identifying and removing hidden surfaces. The objective is to understand concept of hidden surface removal. Hidden surface removal, that is hidden surface elimination, is also called as visibility determination. Consider this diagram, which is a wireframe having different objects like it is having this surface, flat surface. It is also having this cone, cube, and this another object. Here, these lines of the flat surface, then this line of the cone, then all these lines of the cube are not visible. Even these lines of the flat surface are also hidden if these objects are solid. So, if you remove this, then it will give better view of the objects to the observer. Also, if you observe this object, then it looks like that a ring is kept on this flat surface, or some of the observers may also imagine that this portion of the flat surface is cut. So, when the hidden lines are removed, then it gives better view of the object, and here it is clear that it was not a ring but this portion of this flat surface is cut. Also, if you consider colored object and the hidden surfaces are removed, then it again gives much better view of the object to the observer. So it is very important to remove hidden lines and hidden surfaces for more realistic view of the object. So one of the most challenging problems in the computer graphics is the removal of hidden parts of the images of solid objects. In real life, the opaque material of these objects obstructs the light rays from hidden parts and prevents us from seeing them. To remove these parts, to create more realistic image, we must apply a hidden line or hidden surface algorithm to set of objects. Types of hidden surface detection algorithms can be broadly classified as object space method and image space method. In the object space method, it compares objects and parts of the objects to each other within the scene definition to determine which surfaces are visible. And in image space methods, visibility is decided point by point at each pixel position on the projection plane. Let us see backface detection method for hidden surface removal. It is object space method in which objects and parts of objects are compared to find out the visible surfaces. Determination of whether a face of an object is facing backward and therefore it is invisible is performed in the backface detection. In the backface detection, in a solid object, there are surfaces which are facing the viewer, which are called as front faces, and there are surfaces which are opposite to the viewer, which are called as back faces. These back faces, which are opposite to the viewer, contribute to approximately half of the total number of surfaces in the solid object. So, because we cannot see these surfaces, to save the processing time of the other algorithms, we can remove these back faces before the clipping process within a simple test. Each surface has a normal vector. If this vector is pointing in the direction of the center of the projection, it is a front face. and it can be seen by the viewer. If this normal vector is pointing away from the center of the projection, then it is a backface and cannot be seen by the viewer, hence should be removed. Mathematically, this is performed using the z component. So, if the z component of the normal vector is positive, then that particular portion is backface. If the z component of the vector is negative, then it is a front face. So, in the backface detection, when the solid object is considered, then this part of the object is not seen. So, it is backface and hence is removed. For the backface detection, we can use the equation of the plane. So, we know that the equation of the plane is ax plus by plus cz plus d equal to 0. Here, a, b, c and d are the plane parameters for the surface and point x, y, z lies on the plane. When the point x, y, z is behind a polygon surface, then ax plus by plus cz plus d is less than 0. It means that the point lies on the negative side and the point xyz is on the front of the polygon. If ax plus by plus cz plus d is greater than 0, that is, the point lies on the side of the polygon surface. So if we consider the right-handed system, then the algorithm for the backface detection for the right-handed system will have the pseudocode like this. First, compute n, that is normal vector, for every face of the object. If c into z component is less than 0, then it means that the particular face is a back face and we should not draw that face. Otherwise, that is a front face and it should be drawn because it is visible to the observer. That is, if the z component of the normal vector is negative, it is a back face, and if z component is positive, it is a front face. So, in the backface detection algorithm, ensure that we have a right-handed system with the viewing direction along the negative z-axis. That is, if this is the x-axis, y-axis and z-axis, and the observer is facing along this negative z-axis. So that is, this is the viewing direction. Then for each surface, when we draw a normal vector like this, so this is of this shaded face. So if the z component of the polygon's normal is less than, then the particular surface cannot be seen by the viewer. So this particular face is not visible to the viewer, so it will have a normal which is less than 0. So in general, backface detection can be expected to eliminate about half of the polygon surfaces in the scene from the further visibility test. So in general, we can say that in the backface detection algorithm, it is fast and simple object-based system. In this algorithm, a point xyz is inside a polygon surface with plane parameters a, b, c, d if ax plus by plus cz plus d is less than 0. When an inside point is along the line of sight to the surface, the polygon must be a back face and cannot be seen. There are some limitations of the algorithm. This method works fine for convex polyhedra, but it may not work well for concave polyhedra. Also, this method can only be used on solid objects modeled as polygon mesh. These are the few references used to prepare this presentation. If you have any queries, please feel free to ask. If you like the video, do share and like this video. Thank you.